Look up right now. There are rivers floating above you, entire oceans suspended in air. The clouds above your head are carrying millions of tons of water right now. That fluffy white cloud, it weighs as much as 100 elephants. Yet it floats. The water inside has been everywhere. Ancient seas, dinosaur bodies, your grandmother's tea. Now it's above you, quiet and patient. Tonight, we discover what clouds really are. Get comfortable. Let the day fall away. If you enjoy these quiet journeys through science, I'd love for you to subscribe. You'll join a wonderful community of curious minds who find peace in learning. And if you're comfortable, leave a comment telling me where you're listening from and what time it is there. I love knowing where in the world these words are traveling. Now, let's begin. A cloud is not a thing. Not really. It's an event. It's billions of tiny water droplets deciding all at once to be visible. Think about your breath on a cold morning. You breathe out, and there it is. A little cloud. Then it's gone. That's what all clouds are. Just water that got cold enough, high enough, to suddenly appear. Each droplet in a cloud is incredibly small. So small that millions of them could fit inside a single raindrop. They're smaller than the width of a human hair, smaller than a grain of sand. Each one is barely there at all, but billions of them cluster together. They cling to tiny specks of dust or salt floating in the air. And suddenly, you can see them. From miles away, you can see them. White and fluffy, or grey and heavy. But always, always, just water and air. If you could walk through a cloud, you wouldn't bump into anything solid. You'd just feel mist on your face. Your clothes might get damp. That's all. The cloud isn't a thing you can touch. It's more like a mood the air is having. And here's something beautiful. Every cloud is temporary. That specific cloud, with its specific shape, will be gone soon. Maybe in minutes, maybe in hours. The droplets will evaporate back into invisible vapor. Or they'll grow heavy and fall as rain. But clouds themselves never end. As long as Earth has water and air and sun, there will be clouds. The individual clouds die, but the existence of clouds continues forever. Right now, above you, there are clouds. Maybe thick ones, heavy with coming rain. Maybe thin wisps, barely visible against the blue. Maybe it's night where you are, and the clouds are dark shapes against darker sky. They're not paying attention to you. They're just doing what water does when it rises into cold air. They're just being clouds. Quiet, patient, temporary and eternal at the same time. The water in those clouds will fall someday. It will soak into soil. It will fill rivers. It will be drunk by animals and plants, and maybe even you. Then it will evaporate again, rise again, become a cloud again. This has been happening for billions of years, long before humans were here to name clouds or wonder about them, long before there were eyes to see them, and it will keep happening long after we're gone. That's what you're looking at when you see a cloud. You're watching water on a journey it's been taking since the Earth was young. You're seeing something ancient and something brand new, all at once. Tonight, we're going to follow that journey. We're going to understand how clouds are born, how they live, how they die. We're going to learn what they're made of and why they float and what they do for our world. But more than that, we're going to let them calm us, because there's something deeply peaceful about clouds, something about their slow movement across the sky that makes the mind quiet. So, let's begin at the beginning. Let's talk about how a cloud is born. Water is restless. It never stays in one place for long. Right now, Water is evaporating from oceans, from lakes and rivers, from puddles on sidewalks and dewdrops on grass, from your skin, from your breath. Every exhale you make releases water vapor into the air. This water is invisible. You can't see it. It's just individual water molecules scattered in the air, bouncing around with oxygen and nitrogen and everything else air is made of. The warm sun heats the earth. The earth heats the air. And warm air does something wonderful. It rises. So all that invisible water vapor rises with it. Up and up. Higher than trees. Higher than buildings. Higher than mountains. As it rises, the air gets colder. This is important. Up high, the air is always colder. And cold air can't hold as much water vapor as warm air can. So, as the water rises and cools, it starts looking for something to cling to. It wants to become visible again. It wants to turn back into liquid. High in the sky, there are tiny specks everywhere. Dust from deserts, blown up by wind, salt crystals from ocean spray, smoke from fires, pollen from plants, even bits of meteor dust that burned up in the atmosphere. These specks are so small, you'd need a microscope to see them. But they're everywhere, billions of them floating. The water vapor finds these specks, and it clings to them. One water molecule lands on a dust speck, then another, then another. The speck gets covered in water. It becomes a droplet, still tiny, still almost nothing, but now it's liquid again. This happens to millions of specks at once. Millions of droplets form, all at the same height, where the air is just cold enough, all clustering together. And suddenly, there's a cloud. It didn't exist a moment ago. Now it does. This is the birth. The droplets are so small that air can hold them up. Gravity pulls on them, yes, but the air is rising, pushing up, and the droplets are light enough that the air wins. They float. More water vapor rises. More droplets form. The cloud grows. From the ground, you might see it appear. A small white puff in a blue sky. Growing, building, taking shape. The cloud will move with the wind. It will change shape. It will grow or shrink depending on the air around it. It might rain. It might evaporate. It might last for hours or disappear in minutes. But for now, it's here. A cluster of water droplets clinging to dust specks, floating in cold air, visible and beautiful and temporary. This is happening right now, above you, above everyone. Clouds are being born every second of every day. Water is rising, cooling, clinging to dust, becoming visible. It's one of the most common events on Earth, and one of the most magical. On a summer afternoon, you can lie on your back and watch clouds build. See them puff up, grow taller, spread wider. You're watching birth in real time. And later, you might watch them fade, see them thin and disappear. Water turning back into invisible vapor. The cloud dying as quietly as it was born. Birth and death happening overhead all the time. Peaceful, natural, beautiful. Every cloud you've ever seen started this way. Water vapor, finding dust, cooling, condensing, becoming visible. It's been happening since Earth first had an atmosphere and oceans, and it will keep happening as long as the sun shines and a water exists. The cloud above you right now was born recently, maybe minutes ago, maybe hours. It rose from the ocean or a lake or a forest. It found the cold air. It found the dust, and it appeared. Soon it will die. The droplets will evaporate or fall as rain. The cloud will cease to exist in that exact form. But another cloud will take its place. Water will keep rising. Dust will keep floating. And clouds will keep being born. This cycle never stops, never rests. As constant as the sunrise, as reliable as the tides. Water up, water down, invisible, visible, birth, death, again and again. And we get to watch it happen. Not all clouds live at the same height. The sky has layers, and each layer has its own kind of cloud. The lowest clouds are the ones you know best, the grey ones on rainy days, the fog that hugs the ground on quiet mornings. These clouds form just a few 100 feet up, sometimes even lower. You could climb a hill and be inside one. You could fly a drone into one. They're close enough to feel familiar, close enough that birds fly through them without thinking twice. These low clouds spread across the sky in sheets of grey or white. When they're on the ground, we call them fog. When they're just above it, we call them clouds, but they're the same thing. Then there are the middle clouds. These form around 6,000 to 20,000 feet up. That's where airplanes cruise when they're climbing or descending. Passengers look out the window and see these clouds passing by. Middle clouds are often made of water droplets, but sometimes they're cold enough to have ice crystals too. The air up there is near freezing, even on a warm summer day. These clouds can be fluffy or flat. They can be white or grey. They're the ones you see most often when you look up on a partly cloudy day. But then there are the high clouds, the ones that form at 20,000 feet and above. Up there, the air is thin and bitterly cold, always below freezing. Water can't stay liquid. So these clouds are made entirely of ice. High clouds are wispy, delicate. They look like brushstrokes painted across the blue. They're beautiful, almost fragile looking. But they're not fragile. They exist in a place where humans can't breathe, where the air pressure is so low it would make you dizzy, where the temperature never rises above zero. Some clouds reach even higher. Storm clouds, the tall ones that bring thunder and lightning, can grow to 50,000 feet or more. That's almost 10 miles high. That's the edge of where weather happens. Above that is the stratosphere. Not many clouds up there. The air is too thin, too stable. But on rare occasions, in the coldest parts of the world, clouds form even higher, at 80,000 feet, 15 miles up. These are the highest clouds on Earth. They're so high, they catch the light of the sun even after sunset. They glow against the dark sky, blue and silver and ghostly. Most people never see them. They only appear in summer, only at high latitudes, only when conditions are perfect. But they're there. So when you look at the sky, you're seeing layers. Low clouds floating past, middle clouds above them, high clouds streaking across the top, each level moving at its own speed, shaped by its own winds. The sky is deeper than it looks. It's not a flat dome. It's a space with depth and dimension, and clouds fill that space, top to bottom, each one at the height where it can exist. Some days, all three levels are visible at once. You see the low grey clouds, the middle white puffs, the high wispy streaks, 3 layers of water and ice, all floating, all moving, all temporary. Other days, there's just one layer, just low clouds covering everything, or just high clouds barely there. But always, the sky has room for clouds at every level, from just above your head to the edge of space. Water finds a way to float at every height where the air is cold enough, and each height has its own personality, its own pace, its own kind of beauty. The low clouds move slowly, heavy with moisture. The middle clouds roll and shift. The high clouds race across the blue, pulled by winds so fast they could cross a continent in a day. All of them water, all of them temporary, all of them beautiful in their own way. Not all clouds live at the same height. The sky has layers, and each layer has its own kind of cloud. The lowest clouds are the ones you know best, the grey ones on rainy days, the fog that hugs the ground on quiet mornings. These clouds form just a few hundred feet up, sometimes even lower. You could climb a hill and be inside one. You could fly a drone into one. They're close enough to feel familiar, close enough that birds fly through them without thinking twice. These low clouds spread across the sky in sheets of grey or white. When they're on the ground, we call them fog. When they're just above it, we call them clouds. But they're the same thing. Then there are the middle clouds. These form around 6,000 to 20,000 feet up. That's where airplanes cruise when they're climbing or descending. Passengers look out the window and see these clouds passing by. Middle clouds are often made of water droplets, but sometimes they're cold enough to have ice crystals too. The air up there is near freezing, even on a warm summer day. These clouds can be fluffy or flat. They can be white or grey. They're the ones you see most often when you look up on a partly cloudy day. But then there are the high clouds, the ones that form at 20,000 feet and above. Up there, the air is thin and bitterly cold, always below freezing. Water can't stay liquid. So these clouds are made entirely of ice. High clouds are wispy, delicate. They look like brushstrokes painted across the blue. They're beautiful, almost fragile looking, but they're not fragile. They exist in a place where humans can't breathe, where the air pressure is so low it would make you dizzy, where the temperature never rises above 0. Some clouds reach even higher. Storm clouds, the tall ones that bring thunder and lightning, can grow to 50,000 feet or more. That's almost 10 miles high. That's the edge of where weather happens. Above that is the stratosphere. Not many clouds up there. The air is too thin, too stable. But on rare occasions, in the coldest parts of the world, clouds form even higher. At 80,000 feet, 15 miles up, these are the highest clouds on Earth. They're so high, they catch the light of the sun even after sunset. They glow against the dark sky, blue and silver and ghostly. Most people never see them. They only appear in summer, only at high latitudes, only when conditions are perfect. But they're there. So when you look at the sky, you're seeing layers. Low clouds floating past, middle clouds above them, high clouds streaking across the top, each level moving at its own speed, shaped by its own winds. The sky is deeper than it looks. It's not a flat dome. It's a space with depth and dimension, and clouds fill that space, top to bottom, each one at the height where it can exist. Some days, all 3 levels are visible at once. You see the low grey clouds, the middle white puffs, the high wispy streaks. 3 layers of water and ice, all floating, all moving, all temporary. Other days, there's just 1 layer, just low clouds covering everything, or just high clouds, barely there. But always, the sky has room for clouds at every level, from just above your head to the edge of space. Water finds a way to float at every height where the air is cold enough, and each height has its own personality, its own pace, its own kind of beauty. The low clouds move slowly, heavy with moisture. The middle clouds roll and shift. The high clouds race across the blue, pulled by winds so fast they could cross a continent in a day. All of them water, all of them temporary, all of them beautiful in their own way. Humans love to name things. We name stars and mountains and rivers. We name our pets and our cars and sometimes our plants. And we've named clouds too. not individual clouds. You can't name a specific cloud. It won't exist long enough to remember its name. But we've named the types of clouds, the shapes they make, the ways they appear in the sky. The most famous cloud name is cumulus. You know this cloud, even if you don't know the name. It's the puffy one, the cotton ball, the cloud from children's drawings. Cumulus means heap in Latin, a pile. And that's what these clouds look like. Piles of white, stacked on top of each other, with flat bottoms and rounded tops. They form on warm days when the air is rising strongly. Each puff is a column of rising air, cooling and condensing into visible water. They're happy clouds, cheerful. They mean good weather. Then there's stratus. This means layer. Stratus clouds are flat. They spread across the sky like a blanket, grey and even. Stratus clouds form when air rises gently, evenly, not in columns, but in sheets. They don't pile up, they just spread, and they often bring light rain or drizzle, the kind of rain that lasts all day. High in the sky, there are cirrus clouds. Cirrus means curl of hair. These clouds are wispy, thin, made of ice crystals instead of water droplets. They streak across the sky in white lines. Cirrus clouds mean the weather might change soon. They often appear before a storm system moves in. They're the warning clouds, the messengers. There are combinations too. Stratocumulus, cumulus clouds that spread into layers. Cirrostratus, high, thin layers of ice clouds. Cumulonimbus, the storm cloud, the giant. Cumulonimbus clouds are the most dramatic. They tower miles high. They're dark at the bottom and bright white at the top. They bring thunder and lightning and heavy rain. They're clouds with power. The word nimbus means rain. Any cloud with nimbus in its name is a rain cloud. Nimbostratus, cumulonimbus, clouds that aren't just floating, clouds that are about to give their water back to the earth. These names were created by a man named Luke Howard in 1802. He watched clouds all his life. He studied them, and he realized they fell into patterns, types. So he named them. His names stuck. Meteorologists around the world still use them. Scientists studying clouds in China and Brazil and Norway all use the same Latin words. It's a shared language, a way to describe what we see when we look up. And there's something comforting about that, knowing that the cloud above you has a name, that someone looked at it 200 years ago and called it the same thing. Clouds are temporary. They change and disappear. But their types are eternal. There will always be cumulus. There will always be stratus. There will always be cirrus. The individual cloud is unique. It will never exist again in exactly that shape. But the type of cloud it is has existed for billions of years. When you learn the names, the sky becomes more readable. You start to see patterns. You notice when cumulus clouds are building taller. You recognize the thin veil of cirrostratus moving in. You know what the clouds are telling you about the air. The sky is always speaking. The clouds are the words. And now you're learning to read them, slowly, gently, one name at a time. Cumulus, the heap, the happy cloud. Stratus, the layer, the quiet cloud. Cirrus, the curl, the high cloud. Each one beautiful in its own way. Each one part of the same story. Water rising, cooling, becoming visible, then changing, moving, becoming something else. The names help us hold on to them for a moment. Even though we know they'll be gone soon, they give us a way to talk about something that won't last, to describe something that's always changing, and that's a gift. Light is strange. It seems simple, but it's not. Sunlight looks white or yellow to us, but it's actually made of all colors mixed together. Red, orange, yellow, green, blue, violet. Every color of the rainbow, traveling together as white light. You can see this when light passes through a prism. The prism splits the colors apart, or when sunlight passes through raindrops and makes a rainbow. Same thing, the colors separate and we can see them individually, but most of the time they stay mixed and we see them as white. Now, when sunlight hits a cloud, something happens. The water droplets in the cloud are small, but they're not that small. They're bigger than the wavelength of visible light. This matters. When light hits a droplet, it bounces, it scatters. And here's the key thing. The droplet scatters all colors equally. Red light bounces, blue light bounces, green light bounces. All of them scatter in all directions. None of them get absorbed or filtered out. So all the colors bounce around inside the cloud, mixing together, and come out the other side still mixed, still white. That's why clouds are white. They're scattering all the colors of sunlight equally. And when all colors mix, we see white. It's beautiful, actually. The cloud isn't adding color. It's not choosing certain wavelengths. It's just bouncing all the light back at us in a jumble, and our eyes interpret that as white. But you've seen grey clouds too. Dark clouds, storm clouds. Those aren't a different kind of water. They're just thicker. When a cloud gets thick enough, light can't pass through it easily. The droplets keep scattering the light, bouncing it around, but so much of it gets bounced back out the top or sides that less of it makes it through to the bottom. So the bottom of the cloud looks dark, grey, ominous even, but it's still the same water droplets, still scattering all colours equally. There's just less light making it through. And if you were above the cloud, looking down at it, it would still look white. Because from that angle, the light is bouncing toward you. Pilots see this all the time. Flying above a storm cloud, it looks brilliant white, bright, almost glowing. But people on the ground see it as dark and threatening. Same cloud, different perspective. There's something profound in that. What looks dark from one angle looks bright from another. It's all about where you're standing, where the light is coming from, where it's going. Clouds don't change colour on purpose. They don't decide to be white or grey. They just are what they are. Water droplets scattering light. And we see them differently depending on how much light reaches our eyes. On a bright day, with the sun high, clouds are brilliant white, almost too bright to look at. On an overcast day, with thick clouds blocking the sun, everything looks grey, muted, soft, same physics, different conditions. And at sunrise or sunset, clouds can be pink or orange or red or purple. Not because they've changed, but because the light hitting them has changed. At sunrise and sunset, sunlight has to travel through more of Earth's atmosphere to reach the clouds. The blue light scatters away. Only the red and orange light makes it through. So the clouds catch that red light and scatter it. And they glow. They turn colours that don't seem possible. Magenta, gold, crimson. For a few minutes, the clouds are on fire. Then the sun moves. The light changes. The clouds go back to white. But they're always doing the same thing. Always scattering light. Always bouncing photons in every direction. We're the ones who see them differently. We're the ones who watch them change colour. The clouds themselves don't know what colour they are. They're just doing what water droplets do when light hits them. And that's enough. That's everything. Sometimes clouds rain, but the rain never reaches the ground. You can see this from a distance. Dark streaks falling from the bottom of a cloud. Grey curtains hanging in the air. It looks like rain. It is rain. But halfway down, it disappears. This is called virga. It's a beautiful word for a strange phenomenon. The rain falls from the cloud. Droplets get heavy enough that air can't hold them anymore. Gravity wins. They start falling, but the air between the cloud and the ground is dry. Very dry and warm. As the raindrops fall through this dry air, they evaporate. They turn back into water vapor, invisible again. By the time they reach the level where you're standing, they're gone. No rain hits the ground. No puddles form. The earth stays dry. But the rain happened. It fell. The cloud released its water. The water just didn't make it all the way down. This happens often in deserts, in places where the air near the ground is hot and dry. The clouds are high enough to exist, cold enough to form, but the air below them is hostile to rain. So the rain tries, falls, evaporates, returns to the sky. It's a patient cycle. The water goes back up. It rises as vapor. It cools. It forms a cloud again. It tries to rain again. And maybe this time it makes it. Or maybe it evaporates again. The water doesn't care. It just keeps cycling. There's something peaceful about virga, about watching rain that never lands. It's like watching an effort that doesn't succeed. But the effort itself is beautiful. The streaks hanging from clouds look like jellyfish tentacles, like curtains swaying in wind, like the sky is reaching down to touch the earth, but can't quite make it. And there's no frustration in it. The water isn't trying to accomplish something. It's just following physics, falling because gravity pulls, evaporating because the air is dry, rising because it's lighter than air when it's vapor. No emotion, no disappointment, just water being water. In some places, you can see virga almost every afternoon. The mountains create clouds. The clouds try to rain. The desert air evaporates the rain before it lands. Every day, same pattern, and the desert stays dry. But the attempt continues. The clouds keep forming. The rain keeps falling. The air keeps evaporating it. This is the world's way of balancing things. The desert needs water. The clouds have water. But the air is too dry for the transfer to happen easily. So, the water has to try multiple times. Eventually, a cloud might get thick enough, or the air might get humid enough that the rain makes it through. And when it does, it's a gift, a rare event. Water that fought through the dry air and won. But most of the time, in most deserts, the rain falls and vanishes. And that's okay. That's just how it works. From an airplane, virga is stunning. You look down and see clouds with streaks beneath them. The streaks fade to nothing, just wisps of grey that dissolve into blue. It looks like the sky is crying, but the tears evaporate before they fall. And maybe that's what it is. The sky releasing water it can't hold anymore, letting it fall, not caring whether it reaches the ground, just letting go. There's a lesson in that, maybe, about effort without attachment to outcome, about doing what you're supposed to do without needing a specific result. The rain falls because it must, because it's too heavy to stay in the cloud. That's enough reason. Whether it reaches the ground or evaporates halfway down doesn't change the fact that it fell, doesn't change the physics, doesn't change anything. The water will try again. It always does. And someday, maybe, it'll make it all the way down. But even if it doesn't, even if it evaporates every time, it's still rain, still following the ancient cycle. still part of the system that keeps water moving through the world. Virga, rain that never lands. Beautiful, peaceful, persistent. Clouds move, but they don't all move at the same speed. High clouds race across the sky. They can travel at 100 miles per hour or more. Pulled by winds called jet streams, they cross continents in a day. You can watch them streak across the blue, thin and fast, and gone before you really notice them. Low clouds move slower, much slower. Some travel at walking speed. You can sit and watch one cloud for an hour and see it slowly change position. It's peaceful, meditative. The difference is the wind. High up, winds are strong and fast. They circle the earth in rivers of air, pulling clouds along with them. Low down, winds are slower, interrupted by mountains and buildings and trees. So the high clouds race, the low clouds crawl, and the middle clouds, they move somewhere in between. Not fast, not slow, just steady. But here's something beautiful. That cloud above you right now, it might have started over the ocean, hundreds or thousands of miles away. The water evaporated from the sea, rose into the air, traveled with the wind, cooled, formed a cloud, and now it's above you. It's been places you've never seen. It's crossed mountains and forests and cities. It's been above people speaking different languages, living different lives. And tomorrow it might be gone, moved on to another place, or evaporated, or fallen as rain. Clouds are travelers. They don't stay anywhere long. A cloud that forms over the Atlantic Ocean might rain on Ohio 3 days later. The water molecules inside it have journeyed thousands of miles, seen both coasts, crossed an entire country, and they did it without trying, without knowing. They just moved with the wind. There's something freeing about that, about going where the wind takes you, about not needing a destination or a plan, just moving, just existing, just being carried. Clouds don't resist the wind. They don't try to stay in one place. They move with whatever force is pushing them, and they're okay with it. Sometimes the wind is fast. Sometimes it's slow. Sometimes it changes direction. The cloud just goes along, changes shape, adapts, continues. You can track clouds using satellites now. Watch them move in time-lapse videos. See them swirl and flow like rivers of white across the blue. It's mesmerizing. The patterns they make are beautiful. Spirals around storms, straight lines where jet streams push them, clusters where air is rising, empty spaces where air is sinking. And it's all happening because of wind, because air is always moving, always flowing, always searching for balance. The earth spins. The sun heats some places more than others. Warm air rises, cool air sinks, and in between, wind blows, carrying clouds, carrying water, carrying the weather from one place to another. Without wind, clouds would just form and sit there. They'd rain and disappear, and form again in the same spot. The water cycle would be local, limited, but wind spreads everything out, makes it global. Water that evaporates in the tropics can fall as snow in the Arctic. Water from the Pacific can rain on the Atlantic coast. The whole world shares the same water because clouds move. That cloud above you contains water from everywhere. A bit from the ocean, a bit from a lake, a bit from a forest, a bit that someone else breathed out yesterday. All mixed together, all traveling together, all going wherever the wind decides. And you're seeing it for just a moment, this brief intersection of your life and this cloud's journey. You're both here, in this same place, at this same time. Then it moves on, and so do you. But for this moment, you shared the same sky, the same air, the same space. And maybe that's enough. Maybe that's all we get. Brief moments of intersection, temporary connections. The cloud doesn't mind. It just keeps moving, keeps traveling, keeps being a cloud, and we get to watch. Clouds control the temperature of Earth. They do it quietly, constantly, without any effort. During the day, clouds shade us. Sunlight hits them and bounces back to space. That light never reaches the ground, so the Earth stays cooler than it would be on a cloudless day. You've felt this, a hot summer afternoon, and a cloud passes over the sun. Suddenly, it's cooler. Relief. The temperature drops a few degrees, just because light is being blocked. That's the cloud doing its job, reflecting sunlight, keeping the Earth from overheating. But at night, clouds do the opposite. They trap heat. During the day, the Earth absorbs heat from the sun. At night, that heat radiates back into space. The ground cools. The air cools. That's why nights are colder than days. But if there are clouds, the heat doesn't escape as easily. The clouds absorb some of that heat, radiating up from Earth, and they radiate it back down, so the ground stays warmer, the air stays warmer. Cloudy nights are warmer than clear nights. The clouds act like a blanket. They trap the heat close to Earth instead of letting it escape to space. This is why deserts get so cold at night. No clouds, clear skies, all the heat escapes. The temperature can drop 50 degrees between afternoon and midnight. But in humid places, where clouds are common, nights stay warm. The clouds hold the heat in. It's a balancing act. Clouds cool during the day, clouds warm during the night. Together, they keep Earth's temperature more stable than it would be otherwise. Without clouds, days would be scorching, nights would be freezing, the temperature swings would be extreme, life would be harder, but clouds smooth everything out. They moderate, they balance, they keep things comfortable, and they do this globally. Clouds over the ocean keep the water from getting too hot during the day. Clouds over the poles trap what little heat there is at night. Every cloud, everywhere, is affecting temperature, making tiny adjustments, adding up to a huge effect. Scientists study this carefully. They want to know exactly how much clouds cool during the day and warm at night, how this balance might change as the climate changes, whether more clouds would help or hurt. It's complicated. Different types of clouds have different effects. High, thin clouds trap more heat than they reflect. Low, thick clouds reflect more light than they trap heat. So the type of cloud matters. The height matters. The thickness matters. But overall, clouds keep Earth livable. They prevent extremes. They create stability. Think about that the next time you see a cloud. It's not just floating there looking pretty. It's doing work. It's regulating temperature. It's making the planet more comfortable for everything living on it. And it's been doing this for billions of years, since the first clouds formed on early Earth. They've been cooling days and warming nights, balancing, stabilizing. Life evolved under clouds. We're adapted to a world where clouds exist, where temperature swings are moderate, where the extremes are softened. A world without clouds would be unrecognizable, harsh, difficult. But we don't live in that world. We live in a world with clouds, with shade during the heat, with warmth during the cold, with balance. And we usually don't even notice. We take it for granted. The cloud passes over the sun, and we think, oh, it's cooler now. We don't think the cloud is protecting me from excessive heat. But that's what's happening. Protection, care, balance. The clouds don't know they're doing it. They're just water droplets following physics. But the effect is the same. Earth is more habitable because clouds exist. So tonight, if there are clouds above you, know that they're keeping you warmer than you would be under clear skies. And tomorrow, when clouds block the sun, know that they're keeping you cooler. Silent guardians, invisible protectors, just doing what water does when it floats in the sky. Clouds themselves are silent, completely silent. Water droplets floating in air don't make noise. They're too small, too light, too spread out. You could be inside a cloud and hear nothing from the cloud itself. Just silence. Maybe your own breathing, maybe wind, but not the cloud, never the cloud. And yet, clouds carry sound. They affect how sound travels. They change what we hear. Thunder, for example. Thunder is the sound of air being superheated by lightning. The air expands so fast it creates a shockwave. That's thunder. But the thunder bounces around inside the cloud, echoes, rolls, gets amplified by all those water droplets. So, what could be a sharp crack becomes a long rumble. The cloud spreads the sound out, makes it deeper, longer, more dramatic. Without the cloud, lightning would make a quick snap and be done. But the cloud turns it into something that rolls across the sky for seconds, minutes even. The cloud is a sound chamber, an amplifier, taking one sound and making it bigger. And clouds muffle sound too. On foggy mornings, when the cloud is on the ground, sounds change. They become softer, muted. Distances feel different. You can hear cars, but not as far away as usual. Voices carry strangely. Everything sounds closer, but quieter. That's the water droplets absorbing sound waves, taking the energy out of them, making everything more gentle. Cities are quieter when there's fog. Nature is quieter. The world feels wrapped in something soft. It's peaceful. The muffling effect of water in air. The way fog makes everything calm. And at night, low clouds can trap sound near the ground. Make it travel farther horizontally instead of up into the sky. You might hear things from miles away that you normally wouldn't hear. A train whistle, a dog barking, distant traffic. The sound bounces off the cloud layer above and stays near the ground, traveling, echoing, reaching places it normally wouldn't reach. So clouds are silent, but not soundless. They shape the acoustic environment. They change what we hear and how we hear it. High in the sky, clouds exist in near silence. The air is thin. Sound doesn't travel well. Birds don't fly that high. Insects don't live there. It's just water droplets and ice crystals floating in quiet. If you could be there, in the middle of a high cloud, you'd hear almost nothing. Maybe wind, maybe your own heartbeat, but not much else. It would be one of the quietest places on Earth. But down here, where we live, clouds affect our sound world constantly, making things louder or softer, changing how far sound travels, creating acoustic spaces that feel different from cloudless days. A thunderstorm sounds different from other storms. The clouds make sure of that. The rumble is deeper because the cloud is thick. The rain sounds harder because the droplets are bigger. A foggy morning sounds different from a clear morning. Everything is muffled, softened, made gentle. And on a clear night with no clouds, sound travels up and away. The sky is open. Noise dissipates into space. It's harder to hear distant things. But on a cloudy night, the sound stays trapped, bounces back, travels sideways. You hear more, even though you're hearing the same amount of noise. The clouds are doing this, shaping the world of sound without making a sound themselves. It's one of the invisible ways they affect us. We don't think about it. We don't notice. But it's happening. The acoustic world we live in is partly created by clouds, by whether they're present or absent, by how thick they are, by how low they hang. And so, clouds are part of the soundscape. Even though they're silent, they're like the walls of a room. The room itself doesn't make noise, but it shapes every sound that happens inside it. Clouds are the walls of the sky, and they shape every sound that travels through air, quietly, invisibly, constantly. Fog is just a cloud on the ground. That's all it is. Same water droplets, same science, same physics, just formed close to Earth instead of high above. The process is identical. Air cools, water vapor condenses onto dust particles. Droplets form. Billions of them cluster together. They become visible. The only difference is height. Clouds form up there. Fog forms down here. But they're the same thing. When you walk through fog, you're walking through a cloud. Your face gets wet from the tiny droplets. Your clothes absorb moisture. You're inside a cloud, experiencing it from the inside instead of looking at it from below. And it feels different from looking at clouds. It's more intimate, more immediate. The cloud is touching you. Everything looks different in fog. Distances disappear. You can't see far. Objects appear out of nowhere as you get close to them, then disappear again as you walk past. The world shrinks. It becomes just what's near, what's visible. Everything else ceases to exist until you reach it. There's something peaceful about that. The way fog limits your world, makes it small, manageable, contained. You can only deal with what's right in front of you. You can't see the distant mountains or the far side of the lake, or the buildings a mile away. You can only see here, now, this, and so the mind quiets. There's nothing to think about except the immediate, the present, the next few feet ahead. Fog forms in different ways. Sometimes the ground cools overnight. The air above it cools too. Water condenses. Fog appears. This happens on clear nights when heat escapes to space. The ground gets cold, the air gets cold, and if there's enough moisture, fog forms. By morning, the sun comes up, the ground warms, the air warms, the fog evaporates. It doesn't go anywhere, it just turns invisible again, back to water vapor. Other times, fog forms when warm, moist air moves over cold ground or cold water. The air cools rapidly. Water condenses. Fog appears. This is how fog forms over the ocean. Warm air from the tropics moves north, hits cold water, cools, becomes fog. Thick, dense fog that can last for days. Ships move slowly through it. Horns blow. Navigation becomes difficult. The fog is everywhere, heavy and wet and persistent. But it's still just a cloud, just water droplets, just air that got too cold to hold its moisture. Valley fog is common too. Cold air sinks into valleys at night. Warm air stays on the hills. The valley fills with fog while the peaks are clear. People living on the valley floor wake up to thick fog. People living higher up see sunshine. Same morning, different experience. All because cold air is heavier than warm air. Fog can be beautiful. It softens everything, makes hard edges gentle, turns the world into something dreamlike. Trees appear as silhouettes. Buildings fade to grey shapes. People emerge from the mist and disappear back into it. Colours mute. Sounds dampen. Everything becomes quiet and soft and slightly unreal. But fog can be dangerous too. Driving is harder. Walking is disorienting. You can get lost in fog, even in familiar places, because you can't see landmarks. The fog doesn't care. It's just doing what water does when air gets cold near the ground. It's just existing, being itself, and eventually it will lift. The sun will warm the air. The droplets will evaporate. The fog will rise up and become a cloud again. Or it will disappear entirely, turning back into invisible vapor. But while it's here, it's a gift, a chance to be inside a cloud, to experience what it's like to be surrounded by water droplets, floating in air, part of the same physics that creates every cloud in the sky. Fog, cloud, same thing, different height. And we get to walk through it, feel it, be in it. For a little while, we're part of the cloud, and the cloud is part of us. There are clouds so high they glow in the dark. Most people never see them. They only appear in summer, only at high latitudes, only when conditions are perfect, and only after the sun has set. They're called noctilucent clouds. The name means night shining, and that's exactly what they do. They shine at night. These clouds exist at 80,000 feet, 15 miles up. That's the edge of space. That's where the atmosphere is so thin you can't breathe, where the temperature is always far below freezing. Regular clouds don't form that high. The air is too thin, too cold, too unstable. But these clouds are different. They're made of ice crystals that form around meteor dust, tiny particles from space that burned up in the atmosphere. The ice clings to them, forms crystals, creates clouds, and because they're so high, they catch sunlight even after sunset. Here's how it works. The sun sets, the ground goes dark, the sky goes dark. But 15 miles up, the sun is still visible. Its light still reaches that height. So the clouds glow, blue-white against the black sky. Thin and delicate and otherworldly. They look like smoke, like ripples, like something that shouldn't exist. Ghost clouds in the darkness. And they're beautiful, stunningly beautiful. People who see them remember them forever. They're that rare, that special. You can only see them in summer because that's when the upper atmosphere is coldest. It seems backward. Summer should be warm. But at 80,000 feet, summer is when temperatures drop low enough for these ice clouds to form, and you can only see them at high latitudes. Places like Scotland, Norway, Alaska, Canada, places where summer nights are short and the sun doesn't dip far below the horizon. The clouds need the sun to be below the horizon for you, but still shining on them. That only happens at certain latitudes, certain times of year. Most people live too far south. Most people never have the chance to see them. But for those who do, it's magic. The sky is dark, stars are visible, and there, in the west, or sometimes overhead, are these glowing clouds, electric blue, silvery, moving in waves. They're so high that wind patterns are different. They move in ways that low clouds don't. They ripple, they flow, they form structures that look almost artificial. Scientists study them, try to understand them. They're a relatively recent phenomenon, historically. People only started reporting them in the 1880s. Before that, no records exist. Maybe they didn't exist before then. Maybe something changed in the upper atmosphere. Maybe volcanic eruptions added dust. Maybe human activity changed something. Or maybe they did exist, but people didn't know to look for them. They're subtle, easy to miss if you're not paying attention. Either way, they're here now, glowing in the summer night sky for anyone patient enough to watch for them. They're a reminder that Earth's atmosphere has layers we don't think about, heights we don't imagine, phenomena we rarely see. Most of the time, We think clouds are low things, weather things, rain things, but some clouds exist almost in space, so high that astronauts can see them from above, so high that they're more connected to space than to Earth. And yet, they're still clouds, still water, still following the same basic physics, just in an extreme environment, just at the edge of what's possible. Noctilucent clouds, night-shining clouds, the rarest clouds, the highest clouds, the most beautiful clouds. Most of us will never see them, but knowing they exist is enough. Knowing that somewhere on summer nights, in the far north or far south, there are clouds glowing in the darkness. Ghost clouds, space clouds, impossible clouds, just water and ice and meteor dust, catching the last light of the sun, shining. How long does a cloud live? It depends. Small clouds appear and vanish in minutes. You look up and see a little puff. You look away. You look back. It's gone. The droplets evaporated. The water turned back into invisible vapor. The cloud died as quickly as it was born. This happens constantly. Clouds forming and dissolving, appearing and disappearing. The sky is always changing, but large clouds can last for hours. A big cumulus cloud might exist all afternoon, growing, shrinking, changing shape, but persisting. And storm systems can last for days. The clouds in a storm are constantly being replaced, but the storm itself continues. New clouds form as old ones dissipate. The system persists even though the individual clouds don't. So the answer is, clouds are both incredibly temporary and surprisingly persistent. It depends on what you're measuring. An individual cloud, with its specific shape and location, might last minutes or hours. But cloud systems can last days or weeks. And clouds as a phenomenon have existed for billions of years. As long as Earth has had water and atmosphere, there have been clouds. So each cloud is temporary, but clouds themselves are eternal. Think about that. The specific cloud above you right now is unique. It will never exist again in exactly that form. Once it dissipates or rains or changes, it's gone forever. But clouds in general will exist forever, or at least as long as Earth has oceans and sun and atmosphere. The individual dies. The type continues. It's the same with everything, really. You are temporary, but humans continue. This tree is temporary, but trees continue. This wave is temporary, but the ocean continues. Clouds teach us this, show us the relationship between the individual and the whole, between the temporary and the eternal. That cloud up there will be gone soon, but there will always be clouds. The water in that cloud has been cycling for billions of years. It's been in countless clouds before this one. It will be in countless clouds after. The cloud is new. The water is ancient. Scientists can sometimes track individual clouds using satellites. Watch one cloud form over the ocean, move over land, grow into a storm, rain, and dissipate. The whole life cycle, birth to death, captured in images, and it's beautiful, seeing the progression, seeing how the cloud changes, how it interacts with the air and the land and other clouds. But even with satellites, it's hard to say exactly when one cloud ends and another begins. Clouds merge, they split, they blend together. Is it one cloud or two? Where does one end and the next begin? These questions don't have clear answers. Clouds are fuzzy, not just in how they look, but in how they exist. Their boundaries are unclear. Their identities are uncertain. Maybe that's appropriate. Maybe clouds are meant to be ambiguous, temporary, indefinable. They exist, then they don't. Then they do again, somewhere else, in a different form. The water that was in a cloud yesterday might be in your glass today. It might be in a different cloud tomorrow. It might be in the ocean next week. The water is constant. The form is temporary. And so clouds remind us not to hold on too tight, not to think that what we see right now will last forever. Because it won't. It will change, disappear, become something else. But the essence remains. The water continues. The cycle persists. A cloud lives for as long as it lives, minutes or hours or days, and then it's gone. But it was real while it existed. It was beautiful. It mattered. And that's true for everything, for everyone. We exist for a while. We're visible for a while. We have our moment in the sky. And then we change, become something else, return to the cycle. But while we're here, while we're visible, we're real. We're part of the world. We're contributing to the whole. Just like clouds, temporary, essential, beautiful, here, then gone, then here again in a different form. Earth isn't the only world with clouds, but our clouds are special. Venus has clouds, thick, dense clouds that cover the entire planet. You can't see the surface from space, just clouds, layer after layer of them. But they're not water clouds. They're made of sulfuric acid. Sulfuric acid droplets floating in carbon dioxide atmosphere. Poisonous, corrosive, hostile to life. These clouds are so thick they trap heat like a blanket. Venus is the hottest planet in the solar system because of them. Hotter than Mercury, even though Mercury is closer to the Sun. The clouds create a runaway greenhouse effect. Heat gets in but can't escape. The surface is 900 degrees Fahrenheit, hot enough to melt lead. Earth's water clouds cool the planet. Venus's acid clouds cook it. Mars has clouds too. Thin, wispy clouds made of water ice. They form in the early morning, low in the valleys. By afternoon, they're gone. Mars also has dust storms that can cover the entire planet. These aren't clouds exactly, just dust lifted by wind. But they fill the sky, block the sun, turn the sky orange-brown instead of the usual pink. And on cold winter nights at the Martian poles, clouds of frozen carbon dioxide form, dry ice clouds, something Earth never has. Jupiter's clouds are massive, hundreds of miles thick, made of ammonia and water and other compounds. They form bands around the planet, swirling, mixing, creating storms that last for centuries. The Great Red Spot is a storm system bigger than Earth. It's been raging for at least 400 years, maybe longer. The clouds in it rotate, swirl, create patterns we can see from 1 billion miles away. Jupiter's clouds are colourful, red and brown and white. The colours come from different chemicals at different heights. Sulfur compounds, phosphorus, ammonia, nothing like Earth's simple white water clouds. Saturn has clouds too, similar to Jupiter's. Ammonia and water, thick and layered, creating bands and storms. But Saturn also has a hexagon at its north pole, a cloud pattern shaped like a perfect hexagon. Each side is wider than Earth. It rotates with the planet. No one knows exactly why it forms this shape. It's one of the mysteries of the solar system, a geometric cloud pattern, stable for decades. Titan, Saturn's largest moon, has clouds, but not water clouds, methane clouds. Methane is a gas on Earth. On Titan, it's cold enough that methane acts like water does here. It evaporates from lakes, rises into the atmosphere, cools, forms clouds, falls as rain, fills the lakes again. Titan has a methane cycle, just like Earth has a water cycle. Same process, different substance. And there are planets around other stars with clouds we can only imagine. Hot Jupiters with clouds of molten rock. Super Earths with clouds of exotic chemicals, worlds we haven't even discovered yet. But Earth's clouds are special. They're made of water, simple, life-giving water. They're transparent. They let light through. They don't hide the surface. They don't trap too much heat. They moderate temperature. They bring rain. They make life possible. No other planet we know of has clouds like ours. So perfect for life. So balanced. So beautiful. Venus's clouds are toxic. Mars's clouds are too thin. Jupiter's clouds are too thick. Titan's clouds are too cold. Earth's clouds are just right. And that's rare. Incredibly rare. In all the universe, in all the billions of planets, Earth's water clouds might be unique. Or maybe they're common. Maybe there are billions of worlds with water clouds. We don't know yet. But for now, Earth is the only place we know of where you can look up and see simple, beautiful, life-giving water clouds. That makes them precious. That makes them worth appreciating. Our clouds, our water, our perfect, balanced, beautiful sky. We're lucky to have them. Lucky to live under them. Lucky to be on a world where water floats in the air and falls as gentle rain. Clouds on other worlds are fascinating, but they're not home. They're not ours. These clouds are. The ones above you right now. Water clouds, earth clouds, home. Sunsets are one of the most beautiful things in nature, and clouds make them even better. Here's why sunsets are colourful. During the day, when the sun is high, its light travels straight down through the atmosphere. It doesn't have to go through much air. But at sunset, the sun is low on the horizon. Its light has to travel sideways through the atmosphere, through much more air, through miles and miles of it. And air scatters light. Specifically, air scatters blue light. Blue light has a short wavelength. It's easily scattered. So, as sunlight travels through all that air at sunset, the blue light gets scattered away in all directions. It bounces around. It leaves the beam. What's left is red light, orange light, yellow light. These have longer wavelengths. They don't scatter as easily. They make it through all that air. So the sunlight reaching the clouds at sunset is red and orange, not white, not blue, just the warm colours. And the clouds catch this light. They scatter it. They glow with it. A white cloud in the afternoon becomes a pink cloud at sunset, an orange cloud, a purple cloud, a gold cloud. The colours can be stunning. Magenta, crimson, peach, salmon, colours you didn't know the sky could make. And it's all because of the angle of the sun and the scattering of light through air. The clouds themselves haven't changed. They're still water droplets, still scattering all wavelengths equally. But the light hitting them has changed. It's red now instead of white. So they scatter red light, and they look red. The thicker the cloud, the more dramatic the colour. Thin clouds glow softly, thick clouds burn bright. And the different layers of clouds can show different colours at the same time. High clouds might be pink, while low clouds are orange. Or the tops of clouds might be gold, while the bottoms are purple. It creates layers of colour, depth, dimension. The sky becomes a painting, and it only lasts a few minutes. The sun keeps moving, the angle changes, the colours shift. What was pink becomes orange. What was orange becomes red. What was red becomes grey. Then the sun sets completely. The colours fade, the clouds go dark. But for those few minutes, the sky is on fire, and people stop what they're doing to watch. They take pictures, they stand outside, they stare. Because sunset clouds are magic. They're proof that beauty exists, that the world can be stunning, that physics can create art, and it happens every day, every single day. somewhere on Earth, the sun is setting and clouds are glowing. You don't have to do anything to make it happen. You don't have to pay for it. You just have to look up at the right time. Sunrise works the same way, but in reverse. The sun comes up. Light travels through miles of air. Blue scatters away. Red and orange reach the clouds. They glow, but somehow sunset feels more special. Maybe because we're more likely to be awake and outside. Maybe because the day is ending and we're winding down. Maybe because sunset feels like a gift, a reward for making it through the day. Either way, sunset clouds are one of the best things about having an atmosphere, about having water vapor in the air, about having clouds to catch the light. Without clouds, sunsets would still be colourful. The sky itself would be red and orange, but it wouldn't be as dramatic, wouldn't be as layered, wouldn't have those glowing shapes floating in the colour. Clouds make sunsets better. They give the colour something to land on, something to scatter from, something to make visible and bright and stunning. So the next time you see a sunset, thank the clouds. Thank the water droplets floating in air, catching the red light of the sun, glowing for a few minutes before the night comes. They're doing what they always do, just scattering light. But at sunset, with the right angle and the right colours, they create something unforgettable. Beauty from physics, art from science, magic from water and air and light. The water in clouds has been everywhere, literally everywhere. That cloud above you right now contains water molecules that have been on Earth for billions of years. They've been in every ocean, every lake, every river. They've been in ancient seas that don't exist anymore, in glaciers that melted, in forests that became deserts. They've been drunk by dinosaurs, by mammoths, by the first humans, by your ancestors, by you. The water you drank this morning might have been in a cloud yesterday, and before that, in the ocean, and before that, in someone else's body, and before that, in a different cloud. Water cycles, constantly, endlessly. It's always moving, always changing form, but it's always the same water. There's no new water on Earth. All the water we have now is the same water that's been here since the planet formed. Maybe even older. Maybe it came from comets, from space. Either way, it's been recycling for billions of years. Every glass of water you've ever drunk contains molecules that were once in clouds. That fell as rain. That soaked into the ground or filled rivers or became part of the ocean. And every cloud contains water that was once drunk, was once in bodies, was once sweat or tears or spit. It's all the same water, just moving around, changing location, changing state, but never changing its basic nature. H2O, 2 hydrogen atoms, 1 oxygen atom. Simple, eternal. When you drink water, you're drinking history. You're drinking the same molecules that filled ancient Roman baths. That watered the hanging gardens of Babylon. That flowed down the Nile for Cleopatra. The same molecules that were in clouds over prehistoric Earth. That rained on the first life. That filled the first oceans. It's all still here, all still cycling, all still moving through the same patterns. Cloud, rain, river, ocean, evaporation, cloud again, and we're part of that cycle. We drink the water. It becomes part of us for a while. Then we sweat it out, or breathe it out, or excrete it, and it goes back into the cycle, back to rivers or oceans or soil, back to the air, back to clouds. We're temporary storage for water. It passes through us, uses us, then moves on. Just like it passes through trees and grass and animals and soil. Just like it passes through everything living. Water is patient. It doesn't care where it goes or how long it takes. It just keeps cycling, keeps moving, keeps being water. And clouds are part of that cycle, a visible part, a beautiful part. When you see a cloud, you're seeing water on its journey. Water that will fall as rain, that will fill streams, that will be drunk by someone, somewhere, that will become part of a body for a while. Then return to the sky. The cycle never stops, never rests. As long as the sun shines and Earth exists, water will keep cycling, and we get to witness it. We get to drink it. We get to be part of it. Every sip you take connects you to everything, to clouds and oceans and ancient history, to dinosaurs and pharaohs and people who haven't been born yet, because the water you're drinking now will be drunk again by someone else, somewhere else, sometime in the future. It will be in clouds again. It will rain again. It will fill rivers and oceans and glasses and bodies again. The same water, forever cycling, forever moving, forever connecting everything. So the next time you drink water, think about where it's been, what it's been part of, what journey it's taken to reach you, and know that it will keep journeying after you. It will go to clouds, it will fall as rain, it will be drunk again. The water in clouds is the water in you. The water in the ocean is the water in your glass. The water in ancient rivers is the water in today's rain. It's all connected, all one system, all one cycle. And clouds are the visible proof of that. They show us water in transit, water between earth and sky, water on its eternal journey. Gravity pulls on everything, always. Every single thing with mass gets pulled toward Earth. Clouds have mass, millions of tons of it. So gravity pulls on clouds, constantly. Yet they don't fall, they just float there, sometimes for hours. Why? The answer is simple and beautiful. Air is pushing up harder than gravity is pulling down. Think of it this way. Warm air rises. You've seen this. Hot air balloons rise. Smoke rises. Heat rising from pavement on a summer day. This happens because warm air is less dense than cold air. The molecules are moving faster, spreading farther apart. So, warm air weighs less than the same volume of cold air. And when something weighs less than the air around it, it rises. It floats upward. This rising air is everywhere. The sun heats the earth. The earth heats the air above it. That warm air rises. It pushes up. And it pushes up on everything in its way, including clouds. Now, cloud droplets are tiny. So tiny that the upward push of rising air is stronger than the downward pull of gravity on each droplet. So, the droplets don't fall. They stay suspended in the rising air. They float. The cloud as a whole doesn't fall because all its individual droplets are being held up by rising air. It's a perfect balance. Gravity pulls, air pushes, the forces equal out, the cloud floats, but the balance is delicate. If the droplets get bigger, they get heavier. Eventually, they get so heavy that gravity wins. The droplets fall. That's rain. That's what rain is. Cloud droplets that got too heavy to float anymore. They collide with other droplets, merge, grow bigger, heavier, until air can't hold them up anymore. Then they fall, and we feel rain. But until that happens, until the droplets get too heavy, they float, held up by rising air, suspended in the sky. And it's not just rising air. There's also turbulence, swirling air, air moving in all directions. This turbulence keeps droplets bouncing around, never settling, never falling straight down. It's like a leaf falling from a tree. It doesn't fall straight. It twists and turns and floats on air currents. It takes forever to reach the ground. Cloud droplets are even lighter than leaves. They're so light that even gentle air currents can toss them around, keep them aloft, prevent them from falling. So clouds don't fall because the air is strong, stronger than we think, stronger than it seems. We walk through air every day and don't think about it. It feels like nothing, but it's holding up millions of tons of water. It's creating forces strong enough to overcome gravity. Air is powerful. We just don't notice because it's always there, always doing its job, always pushing and pulling and moving. But clouds make it visible. They show us what air can do. They prove that air has strength. Next time you see a cloud, remember this. Remember that it's being held up by invisible forces. That air is pushing up on those water droplets with enough force to keep them from falling. That's physics. That's the world working. That's the balance of forces that makes clouds possible. Gravity never stops pulling, but air never stops pushing. And as long as the push equals the pull, clouds float. It's been this way for billions of years. As long as Earth has had clouds. Gravity pulling, air pushing, droplets floating, and it will keep being this way. As long as the sun heats the earth, as long as warm air rises, as long as water evaporates and condenses, clouds will keep floating, defying what seems possible, making the sky beautiful, all because air is strong enough to hold them up, all because the balance holds, all because physics works every single time, without exception. Some clouds grow tall, incredibly tall, miles high. These are storm clouds, and they're different from regular clouds. Storm clouds form when rising air is strong, very strong. The air shoots upward like a fountain. It doesn't rise gently, it rushes. This happens on hot days when the ground is very warm, or when weather systems collide, or when air is forced up over mountains. Either way, the air goes up fast, and as it goes up, it cools. Water condenses. A cloud forms, but the air keeps rising. So, the cloud keeps growing, taller and taller, higher and higher. Regular clouds stop growing when the air stops rising, but storm clouds keep going. They can reach 50,000 feet, 10 miles high, the edge of the stratosphere. At that height, the top of the cloud is incredibly cold, -80 degrees Fahrenheit. So cold that water can't exist as liquid. It's all ice up there. The bottom of the cloud is still water droplets, but the top is ice crystals. And in between, there's a mix. Droplets freezing, crystals melting, collisions happening constantly. This is where lightning comes from. Inside the cloud, water droplets and ice crystals are moving. Rising air carries droplets up. Gravity pulls ice crystals down. They bump into each other, constantly. Millions of collisions every second. And these collisions create static electricity. Just like rubbing a balloon on your hair creates static. The ice crystals become positively charged. The water droplets become negatively charged. The charges separate. Positive charges accumulate at the top of the cloud. Negative charges at the bottom. The difference builds. The voltage increases. Millions of volts. Billions of volts. Eventually, it's too much. The charge has to balance. The electricity has to flow. And it does. In a flash, in less than a second. Lightning is that flash, that balancing. Electricity jumping from one part of the cloud to another, or from the cloud to the ground, seeking the opposite charge, seeking balance. The lightning heats the air around it to 50,000 degrees Fahrenheit, hotter than the surface of the sun. The air expands so fast, it creates a shockwave. That shockwave is thunder, the sound of air surprised by sudden heat. Lightning happens in an instant, but thunder takes time to reach you. Sound travels slower than light, so you see the flash first. Then you hear the boom. Count the seconds between lightning and thunder. Divide by 5. That's how many miles away the lightning is. 3 seconds means less than a mile. You're close to the storm. 10 seconds means 2 miles. The storm is nearby, but not overhead. If you see lightning but hear no thunder, the storm is too far away. More than 10 miles. The sound doesn't carry that far. Storm clouds can produce lightning for hours, as long as the air keeps rising. As long as droplets and ice keep colliding, the electricity keeps building. Some storms produce 1 lightning strike per minute. Others produce hundreds. The most intense storms light up the sky constantly, flash after flash after flash, and all of it is the cloud trying to balance itself, trying to equalize the charges, trying to return to a neutral state. But it can't. The collisions keep happening, the charges keep building, so the lightning keeps flashing. It's beautiful, terrifying, powerful. A storm cloud is nature at its most dramatic. Water moving, ice forming, electricity building, energy releasing. And it all happens because air rose fast enough to build a cloud miles high, because water droplets collided with ice crystals, because physics demanded balance. Storm clouds remind us that weather is powerful, that clouds aren't always gentle, that nature has force we can't control. But even in their power, there's order, there's physics, there's cause and effect. The cloud rises, collisions happen, charges build, lightning flashes, thunder booms. It's predictable, understandable, natural. Storm clouds doing what storm clouds do, creating one of the most spectacular shows on Earth. The sky is different in the morning than in the evening. The clouds know this. They respond to it. Morning clouds form as the night ends. The ground has been cooling all night. The air above it is cold. If there's enough moisture, it condenses, forms fog, forms low clouds that hug valleys and rivers. These clouds are quiet, gentle. They appear in the stillness before sunrise, when the world is calm and dark. They form because cold air can't hold much water vapor. So the vapor condenses, becomes visible, becomes fog or low stratus clouds. Then the sun comes up, the ground warms, the air warms, and the clouds start to disappear. They don't go anywhere, they just evaporate, turn back into invisible vapor. By mid-morning, they're often gone completely. Morning fog is like this, thick at dawn, gone by 9 or 10. The sun burns it off, not literally, but the warmth makes the water droplets evaporate. Morning clouds are wet clouds. They make everything damp. Dewdrops form, grass is soaked, spiderwebs glisten. Everything is covered in moisture. It's peaceful, the wetness, the quiet, the soft light filtering through fog or low clouds. But evening clouds are different. They build rather than disappear. As the day heats up, the sun warms the ground warms the air rises, and as it rises, it cools. Clouds form. These are cumulus clouds, puffy, growing, building through the afternoon. On some days, they stay small, just puffs, harmless, pretty. On other days, they keep growing, they tower, they darken. By late afternoon, they're storm clouds, and by evening, they're raining. This is the daily cycle in many places. Clear morning, clouds building through the day, storms in the late afternoon or evening. It's predictable. You can set your watch by it. In the tropics especially. Every afternoon, like clockwork, the storms come. The clouds build because the afternoon is the hottest time. The sun has been heating the ground all day. The air rises most strongly in the afternoon, so that's when clouds grow tallest, when they have the most energy, when they're most likely to become storms. By sunset, the air starts to cool again. The rising stops. The clouds stop growing. They start to dissipate, unless they've already become big storm systems. Those can last into the night, even grow through the night. But regular afternoon clouds usually fade by dark, so the pattern is morning clouds that disappear, evening clouds that build. Morning clouds are about the night's cooling. Evening clouds are about the day's heating. Morning clouds are calm. Evening clouds are energetic. Morning clouds hug the ground. Evening clouds tower high. Each time of day has its own personality in the sky, its own kind of clouds, its own mood. Early morning is often the calmest time, the clearest time. The clouds from night have evaporated. The clouds from day haven't formed yet. Just clear sky, blue or pink or orange from sunrise. Quiet. Then morning clouds might form. Fog in valleys, mist over water, low stratus over cities. By midday, those are gone. The sky is blue, or there are a few small cumulus clouds starting to form. By afternoon, those cumulus clouds are bigger, taller, more numerous. By evening, they might be raining, or they might be catching sunset colors, or they might be fading away. By night, the sky is often clear again, or there are different clouds, high, thin clouds, or leftover storm clouds, but not the same clouds as morning. The sky cycles through different states, different cloud types, different moods, and we can watch it happen. We can see the morning clouds disappear, see the afternoon clouds build, see the evening clouds glow at sunset, see the night sky clear. Each time of day offers something different. Each has its own beauty, its own kind of clouds. Morning has stillness, afternoon has energy, evening has color, night has clarity, and clouds show us all of it. Clouds exist in the space between earth and sky, like you exist in the space between waking and sleep. They're always changing, always moving, never quite solid, never quite gone. Just like your mind right now, moving between thoughts, between consciousness and dreams, between awareness and rest. Clouds are perfect for this moment, this transition. They're calming because they're slow, because they're gentle, because they ask nothing of you. You don't have to understand clouds to appreciate them. You don't have to know their names, or how they form, or why they float. You can just watch them. Let them be. Let them move across your mind like they move across the sky. Slow, peaceful, inevitable. The water in clouds has been cycling for billions of years. It's patient. It knows how to wait, how to exist, how to move without hurrying. And tonight, you can be like that, patient, existing, moving towards sleep without hurrying. The clouds above you right now are carrying water from everywhere, from oceans and rivers and lakes, from other clouds that rained and evaporated, from ancient times and future times, all mixed together. They're holding all of this weight, all of this history, and they're doing it without effort, just floating, just being. You can do that too. You can hold what you're holding, your day, your thoughts, your feelings, and you can do it without effort, just floating, just being, just moving towards sleep. Clouds don't fight gravity. They don't resist the wind. They just move with whatever force is acting on them. And they're okay. They exist peacefully. They change shape peacefully. They rain peacefully. They evaporate peacefully. There's no struggle in a cloud, just existence, just physics, just water doing what water does. Tonight, you can be like that. No struggle, just existence, just you doing what you do when the day is done. Moving towards sleep, letting thoughts slow down, letting the mind quiet, like clouds dissipating at sunset, like fog evaporating in morning sun, like water returning to vapor. Gentle, natural, peaceful. Those rivers floating above you are still flowing. The oceans suspended in air are still there. The water that's been everywhere is still cycling. And it will keep cycling while you sleep. It will keep forming clouds and raining and evaporating. The cycle never stops. Just like your breathing never stops. Just like your heart never stops. Just like life never stops. The cycle continues. You can rest in that. You can let go into that. The clouds will be there tomorrow. The sky will be there. The water will still be cycling. And so will you. You'll wake up. You'll continue. But for now, you can rest, like a cloud resting in still air, like water resting in a calm lake before it evaporates again. Rest, peace, the space between. The clouds understand. They're always in transition, always between states, always moving from one thing to another, and they're beautiful because of it, not in spite of it. You're beautiful too, in this transition, in this movement towards sleep, in this space between waking and dreaming. Let the clouds teach you. Let them show you how to be gentle with yourself, how to exist without struggling, how to move without forcing, just floating, just being, just slowly becoming something else. Sleep. If this journey through cloud science brought you peace, I'd be grateful if you'd subscribe. There are more quiet explorations waiting, more gentle science to help you rest. And if you'd like, leave a comment about your favorite cloud memory or what clouds mean to you. I love hearing your thoughts. Until next time, may peaceful clouds float above you. May the water cycle continue its ancient journey. And may you sleep well, knowing that everything is always moving, always changing, always exactly as it should be. Good night.